In this question, in a game of pool, a cue ball with an initial velocity of 1.6 meter per second is directed to the right. So this is where the cue ball is. This is at 1.6 meter per second. This is over on the right. So like this, 1.6 meter per second. And it collides with the 5 ball, which is an equal mass. So this is, let's say, of mass m. Then this is the ball of the 5 ball, which is also of mass m, but this was at rest. After collision, the file ball moves at 1.39 meter per second at 30 degree above the x-axis. So uh, the 5 ball moves like this, right? 30 degree above the x-axis at 1.39 meter per second. So we need to find a cue ball's final velocity along with magnitude and direction, and is the kinetic energy conserved. So let's say the cue ball is actually moving at some velocity vx towards the x direction and some velocity vy towards the minus y direction, and this is the mass m. Okay, so since the momentum is conserved, so the initial momentum is going to be 1.6 times m plus 0 because the 5 ball was at rest, and the final momentum is going to be 1.39 times sorry. So whenever we are conserving the momentum, we have to conserve in x and y direction. So this is, let's say we are conserving towards the momentum about the x direction. So this is the momentum of the x direction, and the final momentum towards the x direction will be given by its component towards the x direction. This is gonna, which is gonna be m times, and the velocity component is 1.39 cosine of 30 degree. That is the velocity towards x component. I mean the momentum towards the x direction, and likewise for the cue ball, that's gonna be m times vx. So it's m. In fact, what we're going to do is the initial and final momentum should be equal. This implies that 1.6 m should be equal to 1.39 cos 30 degree times m plus vx times m. So this m and m is cancelled. Subtracting both sides by this expression, so we have 1.6 minus 1.39 cos of 30 degree, that is equal to vx. So the value of vx from here comes out as, let me just grab my calculator, as 1.39 times cos of 30, and 1.6 minus this value comes out as 0.39, in fact 0.40 meter per second. When we talk about its velocity towards the y direction, so we'll conserve the momentum in the y direction. So in the y direction, we have the initial momentum is 0 because there is no velocity towards the y direction, and the final momentum is going to be its component towards the positive y direction, which is the sine component. So that will be m 1.39 sine of 30 degree, and likewise this component towards the opposite, I mean minus y direction, so that's minus m vy. So this m and m is cancelled, and if we rearrange, then vy comes out as 1.39 sine of 30, which is 1.39 sine of 30 is 0.70 meter per second. But they need the final velocity of the cue ball. So the final velocity is going to be root of vx square plus vy square. So that's going to be root of 0.4 square plus 0.7 square, which will come out as, we just take my calculator. So this is going to come out as 0.80 meter per second, 0.80 meter per second. And if we talk about the direction below the positive x-axis, so basically they are talking about this particular direction. I'll just draw it over here. This is the direction which they are looking for, and this is vx. Let's call the direction as alpha. This is vx and this is vy. So you're going to say that tan of alpha is going to be opposite, which is vy, over adjacent, which is vx. So vy is 0.7, vx is 0.4. This is tan of phi. So the value of phi from here comes out as 7 over 4, and the tan inverse of this value is 60.26 degrees. 60.26 degrees. Finally, they're asking that is the kinetic energy conserved or not. So let's find the initial kinetic energy. The initial kinetic energy is only because of the cue ball, so that's half m 1.6 square. The final kinetic energy is because of the uh, half m for the cue ball. The final velocity is zero point 0.8 m 0.8 square plus half m for the 5 ball. That's 1.39. So this is 1.39 whole square. So this value comes out as m does not have any relevance because that's common in both the cases. So this is coming as 1.28 m joules. In fact, let's not write joules, it will confuse. So this is 1.28 m, and the other one is coming as zero point 0.8 square over 2 plus 1.39 square over 2, which is coming as 1.28 as well. So since the final kinetic energy and initial kinetic energy is same, so yes, the kinetic energy is conserved. Thank you.